There are many importances of SHM. First is to confirm the safety of a structure. Secondly is to spot the potential problem before failure. Thirdly is to understand the best method to maintain a structure. Last but not least, to extend the structure life. There are 5 main structures in SHM, which are pipeline, pressure relief valve, pressure vessel, storage tank, and heat exchanger. In this video, we will focus on the study of pipeline. There are 2 functions of pipeline, which are primary and secondary function. For primary function, pipeline is used to transmit fluid from a location to another. For secondary function, it is used to store fluid. What are the types of pipeline that you know? Well, there are overhead pipelines, underground pipelines, and also submerged pipelines. There are many types of material used to manufacture a pipeline, which consist of carbon steel, cast iron, galvanized steel, stainless steel, and iron steel. So what are the types of defect in pipeline? The defects in pipeline include plugging, leakage, corrosion, deposition, structural damage, deformation, crack, wear, lack of fusion and penetration, material degradation, and excessive vibration. Next, what are the factors of defect in pipeline? The factors are exposure to aggressive environment, build-up stress, corrosion, vibration, external impacts, the moisture of the soil, internal electrolytes, and also erosion of transport materials. Now, let's move on to our SHM strategies. There are 2 strategies in SHM, which are online and offline. Besides strategies, there are 5 types of SHM approaches, which are dynamic monitoring, physical monitoring, temperature monitoring, particle monitoring, and lastly, chemical monitoring. In pipeline monitoring, there are many technologies that can be used through different SHM approaches. Firstly, these are the technologies that can be used under dynamic monitoring. Next, these are the technologies that can be implemented under physical monitoring. As for temperature monitoring, the infrared thermography is able to detect the defects in pipeline. Last but not least, under chemical monitoring, the technologies that can be used to detect the defects in pipeline are piezoelectric transducer and electrochemical tests. Ultrasonic guided wave, also known as UGW, is one of the technologies under dynamic monitoring that used to monitor the defects in pipeline. In order to perform UGW monitoring, the equipments needed are UGW transmission collar and also UGW receiver collar. The function of transmission collar is to excite the guided waves along the pipeline, while the receiver collar will receive the guided waves and generate signals. As you can see here, the UGW transmission collar is placed 1 meter away from the pipe end, while the receiver collar is placed 4 meters away from the transmission collar. For the first monitoring condition, the pipe tested is without failure. During the test, the signals received by the receiver has no change in amplitude. Next, the test is performed on a defected pipeline. As you can see here, there are fluctuations in amplitude of the generated signals. These fluctuations show the area of defect in the pipelines. Hence, It shows that UGW test is able to detect the defects on the inner wall of the pipeline. Next, move on to acoustic emission. In acoustic emission testing, we need speaker and a microphone. The function of the speaker is to generate sound waves that propagate along the pipeline. As for the microphone, it will receive the reflected wave. The pipeline tested consists of a blockage and a leakage. As a result, the reflection signal A and B show the location of the blockage and leakage respectively. This shows that acoustic emission is able to detect and locate the defect in pipeline. Next, move on to the vibration testing of pipeline. In vibration testing, what we need are piezoelectric sensor and the presence of vibration. As we are conducting the vibration testing in a laboratory, the vibration will be generated from a hammer. As the hammer hits the surface of the pipeline, it will generate extra vibrations to the structure. Hence, there will be fluctuation in the signal generated. Based on the previous three monitoring methods, the comparison has been made in terms of the frequency range. Based on the table, UGW has the highest range, which is from 20 kHz to 20 MHz. This followed by acoustic emission and vibration testing. From the frequency ranges, the PF interval for each monitoring method can be determined. PF interval is the time between the failure is detected and when it has failed. The longer the PF interval, the better the method will be. Based on the frequency ranges, the following graph shows the PF interval of UGW, vibration testing, and acoustic emission. In a nutshell, UGW is the best method in SHM compared to acoustic emission and vibration testing in detecting the failure of pipeline. It is able to detect the potential failure the earliest among the three methods, as shown in the PF interval before. UGW can detect even the smallest failure because its frequency range is the highest.